Hello. So today we'll discuss a very new topic. New topic is all about the bonding of molecules. As we go in the chemical bonding chapter, from the starting from the Lewis bonding, sharing of electrons, it happens in order to fulfill its octet. So first theory was that Lewis theory. Then we have come across the theories like valence bond theory, VSEPR theory, like that. আমি সেইকেইটা theory চালো. Now, আমি এটা new theory চাম about the molecules. Why the molecules are so stable? Why some of the molecules are not stable? Just like that. And some molecules show magnetic behaviors and some molecules do not. This is like this type of properties which cannot be described through the earlier theories. Means the theory, magnetic property of certain molecules cannot be described through the Lewis approach, Lewis and Cauchy approach, like also VSEPR theory. Although they have predicted the structure and the geometry, VSEPR valence bond theory, they are very good theories regarding their shape and geometries. But you see, in every step, chemistry needs explanation. Not only chemistry, science needs explanation. And আমি কেমিষ্ট্ৰিত কি হৈ আছে ভিতৰত এটা মলিকুল বা এটমৰ ভিতৰত কি হৈ আছে আমি নেদেখো তাৰ বিহেভিয়াৰটো কি হ'ব আমি প্ৰেডিক্ট কৰিব নোৱাৰিম কিয় আমি প্ৰেডিক্ট কৰিব পাৰিম মানে আফটাৰ সাম এনালাইসিস আমি এক্সপ্লেনেশন দিব পাৰিব লাগিব সেইখিনি কথাহে আমি চাই আছো এতিয়া এনেকুৱা নহয় যে ম্যাগনেটিক প্ৰপাৰ্টি আমি কোৱা কাৰণে দেখাম নো already it has shown some characteristics we are just giving the reasons correctful reasons why they have shown these properties and what type of molecules again can show this type of behavior okay you are predicting the future outcomes according to this theory আমি হেতুহে চাই আছো so that is why theory is important first of all experiment to নিজে দেখাইছে experiment to নিজে দেখাইছে আমি just follow up কৰিছো যে কিয় দেখাইছে understood okay so we'll go through this topic today this is called molecular orbital theory why we need molecular orbital theory eto kiyo use kora hoise molecular orbital theory that is because in order to explain stability more accurately okay bond order energy and also very important part is magnetic behavior এই property kita অকমান ভালকে বুজিবলে হলে in order to explain these properties of certain molecules we have to go through the molecular orbital theory it was given in 1932 by F. Hunts and Mulligan I remember asile Mulligan or F. Hunts is 1932 so VSEPR theory pisot ahise VBT theory pisot ahise to last theory and it is largely accepted and this theory is very important for further exploration and evaluation of chemistry to বহুত এটা important theory হয় molecular orbital theory to আমি বহুত পিছত পঢ়িবলগীয়া হয় I mean now as of now we do only for class 11 purpose but molecular orbital theory can be applied to polyatomic molecules means who have more than two atoms now we will apply the molecular orbital theory in homonuclear heteronuclear diatomic molecules only okay for hydrogen like carbon monoxide they have diatomic molecules two atoms nitrogen oxygen but it can be applied to many other molecules but it has become more complicated okay we will not do this no need to do this just going to the basic idea in class 11 whatever we need to study about this so 1932 it was established F. Hunts and Mulligan okay so what are the features first of all ami ki sabo laibo that features what are the features in this theory as like other theory, what are the features in this theory? What is the new feature? Okay, we have to go very slowly and one by one you have to understand. First thing is that molecular orbital theory is what? কি হয় মানে এনেকে আমি সিম্পলি বুজিবলৈ হলে আমি কি বুজিম যে as like atomic orbital there are some molecular orbitals. First thing, as like some atomic orbital কোন বিলাক 1s 2s 2p 3s like হেবিলাক হৈছে atomic orbital আৰু সেই atomic orbitalৰ নিচিনাকে আমি কিছুমান কি থাকিব molecular orbital থাকিব সেই molecular orbitalত কি হ'ব ইলেক্ট্ৰন থাকিব understood so atom যেতিয়া লগ হ'ব atom যেতিয়া combine হৈ তাতে কি ফৰ্মেশন কৰিব এটা molecular orbital ফৰ্মেশন কৰিব মানে দুটা atom combine হৈছে suppose দুটা atom combine হৈ দুটা molecular orbital formation হ'ব এই তেনেকুৱা কথা আমি ভাবিব লাগিব so first point is that just like atomic orbital কি থাকে electron they have electron so in molecular orbital they also it also have electron so in an atomic orbital how many electrons it may contain it will contain in an atomic orbital maximum electron is 2 so therefore molecular orbital maximum electron it will contain 2 so basic idea to ki hoy ami duta atoms e combine kori molecular orbital formation koribo ar he molecular orbital ki thakibo electron thakibo okay that is thing আমি আৰু এটা কথা এনেকে চাম যে why we need molecular orbital theory বা molecular orbital theory বেলেগ to কি হয় you see in atomic orbital whenever 1s they have some electron whenever they will go into molecular orbital we will not call as 1s it will be termed as new orbital name মানে এটো definition to মানে এটো বুজিবলে হলে কেনেকে বুজিম যে suppose আমি omelette বনাবলে হৈছে suppose we are making an omelette so we can make the omelette in two ways suppose someone is making the omelette while breaking the egg in a pot suppose small pot like that and he's making two omelets he's cooking he is cooking the two omelets means he break one omelet and break another and make eta hairy banai lise fatty loise okay then he start cooking okay what will happen in this omelet can he identify the inside yellowish part in each part no means আমি দুটা তাত অমলেট তো ভাঙি দুটা দিলু কণী দুটা ভাঙি দিলু ফেটি পেলে আমি অমলেটটা বনাইছো অমলেটটো তেতিয়া ক'ব পাৰিম নেকি এটো কাৰ কুহুম হয় ক'ব পাৰিম নে নোৱাৰো so think like that but if another person making omelette by another method means he is not stirring the two omelets together two eggs together he is running out of time therefore he making an omelette in the pan with breaking the two eggs and giving it the pan so he can understand he can distinguish between the two egg cells means they are yellowish part he can distinguish because he is not combining okay he can easily identify যে কোনটো মানে কাৰ yellowish part হয় কোনটো কণী yellowish part so atomic orbital যেতিয়া combine কৰিব এই কণী first আমি যোনটো আমি exam লৈছো যে whenever these two combine কৰিবলৈ কি কৰিব এটা নতুন বস্তু বনাইছে নতুন হে অমলেটটো বনাইছে নতুন অমলেটটোত কি আছে তাহাতৰ নিজৰ দুইটাৰে কন্ট্ৰিবিউশন আছে দুইটাৰে তাহাতৰ এক দুইটাৰে কন্ট্ৰিবিউশন হৈ পেলে নতুন এটা কণী বনাইছে নতুন এটা অমলেট বনাইছে এটো ঠিক আছে ইটোও বনাইছে বাট তাৰ কিন্তু নিজৰ এটো আইডেন্টিটি লজ হোৱা নাই তাৰ নিজৰ নিউক্লিয়াছটো মানে that the person who is making the second omelette, without stirring, without mixing the two egg, he can identify its nucleus, means yellowish part properly, that this belong to this egg 1 and this belong to egg 2. But in person 1 who is making the omelette by stirring, মানে দুটা মিক্স কৰি যোনে বনাইছিলে, he cannot identify. So just as like that, you have to consider that two atomic orbital will combine, they will form a new orbital. This is called as molecular orbital. How many electron one molecular orbital have? 2 electron it will have. So first point is that. Second point is that in order to have molecular orbital, in order to have molecular orbital, combine কৰিব লাগিব. Two atomic orbitals should combine. Two atomic orbital will combine. এতিয়া যোনে তোনে কৰিব নি? Anybody, any atomic orbital can combine to molecular orbital? No. Only the atomic orbital who is having the proper symmetry. Two atomic orbital will combine to form molecular orbital who have proper symmetry. Proper symmetry and energy. Proper symmetry and comparable energy. So comparable means energy difference should be low. Comparable energy. Understood? Comparable energy. Okay, this thing we need to understand. Very properly. Point number 2, comparable energy. Comparable energy means first point of proper symmetry is more important than comparable energy. Both are important. We have to see. So আমি পাইছিলো যে if I take INA as z-axis, means internuclear axis is z-axis. What are the atomic orbital can combine to give that molecular orbital? Thing is that 1s can combine with 1s, 2s can combine with 2s, 2s can also combine with 2p, 2s can also combine with 2p, but who? Okay, 1s can combine with 1s, 2s can combine with 2s, 2s can combine with 2p, but which 2p? 2p has 3 orbitals. 2p atomic orbital can be divided into, it has 3 orbitals. Which one can be combined? Answer is 2pz. 2s can combine with 2pz because internuclear axis we are taking as z-axis. That is the meaning of proper symmetry. This symmetry is same. Symmetry means same hobo lagibo tahator. And 2s cannot combine with 2py. 2s cannot combine with 2px. Ebilak ami nolong. Proper symmetry and energy. Energy means 2s cannot combine with 3p because energy code has very different. 1s, 2s, 2p, 3s, 3p. You see, this is a very large energy difference between 2s and 2p. 2s and 2p. Comparable energy means although they might not be equal, but the difference should be very low, so that one can reach out to other atomic orbital to form a new molecular orbital. Understood? Proper symmetry and it will have the comparable energy. Symmetry means INA ami z-axis loisu, so INA z-axis loi eto. Okay, and also z-axis lole 2pz can also combine with 2pz, but 2pz cannot combine with 3pz. This is also important. Understood? 2pz combine with 2pz, but 2pz cannot combine with 3pz because energy difference is very high. Okay, so both are the very important part in order to form a molecular orbital. Okay, moving on to the point number 3. Point number 3 is the number of molecular orbital formed. The number of molecular orbital formed is equal to number of atomic orbital. Number of atomic orbital. Means, understood now? Suppose 1s can combine with 1s. You know, what will be the bond if 1s can combine with 1s? According to BBT theory, what type of overlapping? 1s can combine with 1s to form sigma bond. Sigma will be the bond. আমি এই কনসেপ্টটো থাকিব লাগিব সিগমা বন্ড কাৰ কাৰ মাজত হ'ব ফৰ্মেশন সিগমা বন্ড 1s 1s এর মাজত হয় 2s 2s এর মাজত হয় 2pz 2pz এর মাজত হ'ব সিগমা বন্ড just as like that we are going through this আকৌবা মই ৰিপিট কৰিম I am going to repeat this again okay I will recall you for this thing the number of molecular orbital form will be equal to the number of atomic orbitals so example 1s is combining with 1s so if 1s can combine with 1s what will be the bond they have formed? They have formed sigma bond. Okay, it was earlier according to valence bond theory, but here it will be called as sigma 1s molecular orbital. Sigma 1s molecular orbital. So 1s 1s. How many atomic orbital? 2 atomic orbital. 2 atomic orbital. Therefore, one more atomic orbital is molecular orbital is formed. That is 1s star. Okay, 1s plus 1s just as like 2s plus 2s 2s plus 2s 1 1 they will form also sigma 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 means 2s 2s e combine kole ki formation hobo sigma bond formation hobo 2s 2s is combined to form sigma bond therefore it is 2s and this is sigma star 2s this is called the star is called as antibonding molecular orbital ABMO and the sigma is known as molecular orbital and another is antibonding molecular orbital whenever the atomic orbital combine and how many the atomic orbital combine suppose atomic orbital 3 molecular orbital also be 3 suppose atomic orbital is 4 molecular orbital is also be 4 for polyatomic molecules we are considering only homoatomic molecule here okay for simplicity so they will form molecular orbital according to the number of atomic orbital and also in every molecular orbital it will have opposite orbital which is high of energy means sigma 1s and sigma star 1s sigma 2s is also forming another its opposite part is antibonding molecular orbital opposite part antibonding molecular orbital antibonding molecular orbital have high energy than that of bonding molecular orbital okay antibonding molecular orbital has high energy than antibonding molecular orbital but stability is less than that of bonding molecular orbital okay দুটা ফর্মেশন কইলে মলিকুলার অরবিটাল ফর্মেশন কইলে দুটা অ্যাটমিক অরবিটাল দুটা মলিকুলার অরবিটাল এটা আছে মলিকুলার অরবিটাল এটা আছে অ্যান্টিবন্ডিং আকৌ 2s এ কম্বাইন কৰি দুটা বন্ড ফৰ্মেশন কৰিছে দুটা নতুন অরবিটাল ফৰ্মেশন কৰিছে এটা হৈছে মলিকুলাৰ অরবিটাল এটা হৈছে অ্যান্টিবন্ডিং মলিকুলাৰ অরবিটাল আৰু অ্যান্টিবন্ডিং টো কি হ'ব এনাৰ্জি বেছি energy is inversely proportional to the stability we have to remember one thing that energy is inversely proportional to the stability. Energy is inversely proportional to the stability. Therefore, antibonding or stability কম energy বেশি এটো অটোমেটিক্যালি হ'ব ঠিক আছে নেক্সট আমি চাও এটা পয়েন্ট আৰু কোবাৰ চাও ওই যে কৈছো সিগমা ফর্মেশন কৰিব ক'ত পাই ফর্মেশন কৰিব according to theory of valence bond theory we are doing 2s can combine with 2s. Suppose 2pz combine with 2pz. What they will form? They will form sigma 2pz and sigma star 2pz. Sigma 2pz and sigma star 2pz. Because internuclear axis z axis লৈছো তাতে head on collision কৰিব head on collision কৰিলে কি formation হয় sigma bond formation হয় if you are taking INA internuclear axis as z axis the 2pz can combine through head on overlap in order to form two molecular orbitals. One is sigma bonding molecular orbital, another is sigma star 2pz molecular orbital. Okay, so just like that 2py plus 2py. If you consider INA as z axis, INA যদি আমি z axis লওঁ 2py কি ফৰ্মেশন কৰিব কোনটো ফৰ্মেশন কৰিব perpendicular to the INA. You see y axis, if you taking we have to take z axis here in chemistry. For better understanding, we are taking z axis here and y axis is this y axis is perpendicular to the z axis. That means the orbital y is perpendicular to this orbital z orbital. So whenever the perpendicular orbital combine, they will always form pi bond. Here instead of pi bond we will say pi molecular orbital and pi antibonding molecular orbital. Understood? So 2py form 2py and 2py antibonding. So 2px with 2px also form pi 2px and pi star 2px and bonding and antibonding molecular orbital. Okay, just like that we are going through this. Means symmetry and energy. Understood? So we have a proper idea about that. Only the atomic orbitals will combine which have proper symmetry and comparable energy. Point number 2. And the number of atomic orbitals should also equal to the number of molecular orbitals. One molecular orbital is high in energy and one molecular orbital is less in energy. The molecular orbital which is high in energy is called as antibonding molecular orbital, which is less contributing to the stability, and the molecular orbital which is less in energy, high in stability, is more contributing to the stability of that whole molecule. Understood? Okay, so antibonding molecular orbital stability कम energy बेसी, bonding molecular orbital stability बेसी energy कम. Understood? Okay, now one more. We are going to the features. One more feature is important in that. Molecular orbital is, point number 4 is molecular orbital is polycentric. Whereas atomic orbital is monocentric. I think you can understand by simply just by thinking is that an atom is under the influence of only one nucleus. But in case of a molecule, two atoms combine to form a molecule. So partially they have the nucleus. They will have the nucleus means two atoms. Hydrogen and hydrogen, they will combine to form H2. So in the H2, that means this is hydrogen, this is also hydrogen. So it has on its nucleus, So this is a new orbital, it is forming by the sharing of electron. We are calling it as a molecular orbital. And a molecular orbital is under the influence of two nucleus. So if there is a two atoms, means they are forming one molecule. Chlorine, two atoms forming one molecule. How many atoms? Two. How many nucleus they have? Two. So this new orbital the new orbital is forming. The new orbital, very important part is that you have to imagine chlorine, chlorine, chlorine. This is the new orbital is forming. Suppose, and this new orbital is under the influence of two nucleus. If there are three atoms, three nucleus. Okay, so molecular orbital is polycentric, whereas atomic orbital is monocentric. Understood? Point number 5. Point number 5, we have already understood about the molecular orbital is two types, bonding and antibonding. Okay, and molecular orbital also have to be followed. Molecular orbital also have to follow. Molecular also have to follow means in order to fulfill the electrons in molecular orbital, in the same way we have to fill it the Aufbau principle, Hund's rule, Pauli's exclusion principle, all have to be maintained. In order to molecular orbital also have to follow the Aufbau principle. Aufbau principle. Actually, this is not a feature. This is we just going through this point. Aufbau principle, Hund's rule, and Pauli's exclusion principle. Okay, these are the types of features in the molecular orbital theories. More even, what are the important point is that proper symmetry, energy, and thing is that two atomic orbital, two molecular orbital. The name of the molecular orbital is bonding, another is antibonding. Antibonding is high in energy, like in stability. If the number of electron in antibonding is more, we'll go through the next point. Okay, we'll go through the next point. We're not discussing this. Okay, under the application we'll discuss. Okay. Moving on to the next point. As we have already seen the features of molecular orbital theory is that antibonding molecular orbital has high in energy. It has high energy, lower stability. But we have to encounter the reason behind this. Why they have high in energy. Antibonding molecular orbital means sigma 1s and sigma star 1s. Which one will have high in energy? Sigma star 1s. Okay, sigma star 1s and sigma 1 is high in energy. Stability wise, this will be like this. Stability. And this is energy. Okay, but why? Reason to some. We need to discuss the reason, proper reason. So, why I am going through the different books? I have seen a very different. Some of the books are not giving the proper explanation behind this, and some of the books are giving the explanation. So according to that, whatever I have understood and whatever I have analyzed, that I am going to share is that in the bonding molecular orbital, in the BMO, bonding molecular orbital, suppose this is the two atoms combining to form a new orbital. This is the new orbital. In dotted line. New orbital. So in bonding molecular orbital, what it happens, according to the book, it is given that in bonding molecular orbital, electrons are in the internuclear region. Electrons are in the internuclear region of the two nucleus. Means মানে এইটো এটা লৈছো, ইহঁতৰ ইলেক্ট্ৰনছ ক'ত আছে? এই দুটাৰ ভিতৰত আছে। nucleus. The electron is in between the nucleus. Therefore, the electrons are acting as a shielding. Shielding means they are screening the one nucleus from another. Means নিউক্লিয়াছৰ মাজত তাহাঁতি এটা কি কৰিছে, they are shielding the nucleus, two nucleus from one to other. So therefore নিউক্লিয়াছৰ মাজত ৰিপালচন কি হৈছে, কমি গৈছে, আৰু নিউক্লিয়াছ আৰু ইলেক্ট্ৰনৰ মাজত কি হৈছে, এট্ৰেকচন বাঢ়িছে। ঠিক আছে, নিউক্লিয়াছৰ মাজত ৰিপালচনটো কমাই দিছে, তাহাঁতি মাজত সোমাই গৈছে, ইলেক্ট্ৰনখিনি মাজত আছে। Electron density to not electrons actually electron density in molecular orbital, bonding molecular orbital is lie in between the internuclear region means duta nucleus or মাজত আছে। But in case of antibonding molecular orbital, suppose these two combine to form antibonding molecular orbital, electron is not found in the near the internuclear region. They are going away from the internuclear region. Means electron kita ei মাজত নাই। So এটা নিউক্লিয়াছ আৰু নিউক্লিয়াছ দুটা, বুজি পাইছে নে কথাটো? নিউক্লিয়াছ আৰু নিউক্লিয়াছ ইহঁতৰ মাজত যদি ইলেক্ট্ৰন থাকে, এনেকে এটা কথাটো বুজিবলৈ সহজ হ'ব মতে। Now it is more easy to understand this. If there is an electron in between the two nucleus, these electrons are acting, they are shielded the nucleus, attraction bahibo eta nucleus electron. But if their electron are less, electron density is less, they are moving away from like that, suppose like this, although they will not completely go away from the nucleus, but region means their position of electron density in antibonding molecular orbital will be lie away from the nucleus, between the two nucleus. Therefore, this nucleus can repel this nucleus. The shielding effect of electrons decreases. The shielding effect of the electron decreases. Therefore, electron repulsion বেছি হৈ যাব in antibonding molecular orbital, so it will be high in energy, less in stability. Understood? Reason to simple reason আমি কেনেকৈ বুজিম, internuclear distance, internuclear regionত electron density বাঢ়িব, নিউক্লিয়াছ দুটাৰ মাজত ৰিপালচন কম হ'ব, ক'ত, bonding molecular orbital। আৰু নিউক্লিয়াছ দুটাৰ মাজত ইলেক্ট্ৰন যদি নাথাকে, ইলেক্ট্ৰন density decrease হৈ গ'ল, in between the nucleus electron density decreases, therefore nucleus repulsion more will happen in case of antibonding molecular orbital, therefore high in energy. Understood? Okay, now next topic means we are going to the molecular orbital theory, we are doing the explanation like that. Next point is that LCAO, linear combination of atomic orbital. Why molecular orbital have formed? Why they have bonding, antibonding? This explanation is more given by linear combination of atomic orbital theory. মানে এটো এটা সাব টপিক এটা, কিয় কম্বিনেশন হৈছে যে কিয় হৈছে, আমি যেনেকে লুইছৰ এটো ইন অৰ্ডাৰ টু ফিল নোবেল গেছ হেৰি কৰিবলৈ চাওঁ যে বুজিবলৈ চাওঁ, লুইছে কৈছে যে 8টা হ'ব লাগে, কোনটো 8টা কিয় হ'ব লাগে? Why it is 8? Because in order to look alike as the electronic configuration of noble gas. So just like that, molecular orbital theory to combination to exact ami Schrödinger actually egla hoise, electrons are taking as a wave. So wave consider kori asile, or wave equation hole electron wave or equation boli kole ami kuntu sam, Schrödinger wave equation to sam. If you consider electron as a wave, we have to go through the equation of Schrödinger. But Schrödinger wave equation will not be applicable for this type of molecules, means which will have more than one electron. It's become very, very complicated. We cannot solve this equation. We means the scientists who have worked behind this are not able to solve the equation. It will become very, very complicated. They have to use some computational chemistry without the presence of the computer at that time. Therefore, a new, more theoretical approach was proposed, which will be also quite accordance with the Schrodinger equation. অলপ মিল আছিলে গৈ কিবা তেনেকুৱা এটা হ'ল আৰু বাকি ইমান এইবোৰ চাই নাথাকো আমি চাম যে লিনিয়াৰ কম্বিনেশ্যন অফ এটমিক অৰবিটেলটো কি কৰিছে এইটো মলিকুলাৰ অৰবিটেলটোৰ ফৰ্মেশ্যনৰ বিষয়ে কৈছে কেনেকৈ কৈছে চাওঁ সাপোজ ইলেক্ট্ৰনটো কি হিচাপে লৈছে ওয়েভ কনসিডার কৰিছে ওয়েভ এটা ওয়েভৰ আমি কি পাম এটা এম্প্লিটিউড থাকে নে নাথাকে ওয়েভৰ এম্প্লিটিউড থাকে ইট হ্যাজ এম্প্লিটিউড this is the amplitude of this wave suppose this is given by psi a this is given by psi b new wave it is also have like this it will also have like this wave suppose this wave theory বুলি ক'লে ওয়েভত আমি ইন্টারফারেন্স পাম destructive and constructive আমি এটো এপ্লাই করি two theories related to wave will apply in the linear combination of atomic orbitals okay one is this constructive another is destructive wave theory constructive means where if these two wave overlaps in the same phase wave overlaps in the same phase the resultant amplitude will be increasing resultant amplitude increasing means this is positive negative so this should be more like this positive negative so ইয়াত থকা পজিটিভটো যদি ইয়াৰ পজিটিভৰ লগত ওভাৰলেপ কৰে আলটিমেটলি কি হৈ যাব it will be raised in the amplitude simple thing this is called constructive interference of wave positive so আমি wave to consider কৰিলে এতিয়া আমি bonding molecular orbital হেতু কৈছো যে যেতিয়া positive এ ওভাৰলেপ কৰিব আৰু negative এ কৰিব যেতিয়া ultimately it gives rise to a psi a plus psi b which we will call as bonding molecular orbital understood যদি আমি দুটা ওয়েভ লৈছো ইলেক্ট্রনৰ ওয়েভ এটা atomic orbital simple এটা atomic orbital one atomic orbital is given by atomic orbital electron wave is given by psi a and for second atom electron wave is given by psi b for one electron it is given by psi b so these two wave can combine in phase overlap means positive itu উপৰ একদম completely overlap হৈছে positive negative or upward therefore ultimate resultant amplitude is increasing understood resultant amplitude is increasing which leads to the formation of bonding molecular orbital very simple now moving on to the next part I am not going very deep on this because not required I am just giving you the hint means basic idea about that how to bonding molecular orbital antibonding molecular orbital and according to LCAO means linear combination of atomic orbitals okay I am not going to the probability wave probability it is psi a plus psi a b square I am not going through this it is very simple I am giving it very simple here okay in many books it is given our details of this I am not going to that details sorry for that I am not going to that details that probability function this is wave function not probability function psi a plus psi b is square কৰি দিও probability wave function আচ্ছা না যাও the next যদি suppose এনেকৈ স্টার্ট কৰিছো এই ওয়েভটো suppose psi a psi b same atom is same hydrogen this is hydrogen 1 or hydrogen 2 next if the hydrogen 1 electron overlaps with hydrogen electron 2 of hydrogen 2 electron of hydrogen 2 which is given by this but not in phase wave overlaps is not in phase result in the amplitude decrease amplitude to কি হৈ যাব ডিক্রিজ হৈ যাব বুজি পাইছে বলেটো মানে ইয়াৰ পজিটিভ to ইয়াৰ নেগেটিভ টোৰ লগত যদি কৰিছে ইয়াৰ পজিটিভ ইয়াৰ নেগেটিভ to ইয়াৰ পজিটিভৰ লগত ইয়াৰ পজিটিভ ইয়াৰ নেগেটিভ এনেকে উল্টা ভটেকে যেতিয়া কৰিব ultimately which leads to a new wave but this new wave will have very less amplitude to কি হৈ গৈছে ইয়াৰ কমি গৈছে amplitude less and হেতুকে আমি কি বুলি কৈছো আমি anti bonding molecular orbital বুলি কৈছো anti bonding molecular orbital psi a psi b okay it is given by subtraction of wave number subtraction of the wave anti bonding molecular orbital okay two things are very clear if the two waves of the electron দুটা character থাকে wave character থাকে particle character থাকে আমি wave character টো লৈছো it is given by this it is given by two waves in phase overlap কৰিলে বাঢ়ি যাব amplitude bonding molecular orbital out phase যদি overlap not in phase বা out in phase এনেকে লিখিছো মই positive negative positive এনে কৰিলে ultimate resultant amplitude টো কমি যাব এটোকে আমি কি বুলি কৈছো anti bonding molecular orbital which is given by psi a minus psi b understood okay we are going to the final part means the last আমি প্ৰথমখিনি চালো we have seen the first a few features and combination now we going to the energy level diagram from molecular orbital theory which is more important আমি theory খিনি চালো apply কৰিম এতিয়া before that what are the types of molecular orbital form আমি আকৌ এবাৰ again কৰিলো sigma 1s এ formation কৰিলে sigma 1s ৰ লগত combine কৰিলে কি formation কৰিব sigma 1s and sigma star 1s two atomic orbital two molecular sigma 2s এ formation কৰি sorry 1s এ combine কৰিব দেই এটো 1s sigma 1s নহয় বল লিখিছো 1s can combine with 1s to form sigma star 1s and sigma so 2s can combine with 2s to form sigma star 2s and sigma 2s then next 2pz combine with 2pz to form sigma 2pz and sigma star 2pz z to কি হলো মই I am taking here according to the book internuclear axis is z if I take the internuclear axis z there will be head-on collision head-on overlap purely they will join through this okay if they are not head-on collision like they will be overlap like this these two overlap like this will form to the formation of a what type of bonding this is called pi bonding so pi কেতিয়া formation কৰিব RNA কি লৈছো আমি z if the question মই আকৌ দেখাই দিম বেলেগ এটা দেখাই দিম equation 2py it will form pi 2py and pi star 2py suppose question to আমাক RNA যদি চেঞ্জ কৰি দিছে RNA যদি আমাক y দি দিয়ে if the question change its RNA as y axis then what will be the molecular orbital formed by 2py and plus 2py if the internuclear axis is 2py then 2py will form sigma 2py and sigma star 2py বুজি পোৱা হৈছে কথাটো RNA যদি চেঞ্জ কৰি দিয়ে 2py থাকিলে characteristics থাকিলে এটা কি ফৰ্মেশন কৰিব according to VVT theory কি ফৰ্মেশন কৰিব sigma next যদি 2p z আৰু z এতিয়া ইয়াত RNA কি আছে y আছে তাহলে ইহঁতে কি ফৰ্মেশন কৰিব pi bond 2pz and this is 2pz 2 pi star 2pz understood RNA যোনটো থাকিব RNA থকা characteristics to sigma কৰিব RNA characteristic নথাকাতে pi কৰি দিব মানে perpendicular to understood so we have seen this type of molecular orbital will form 1s sigma star 2s sigma star 2s and sigma 2s understood these things I have to tell you about this that RNA change hole je if you change the RNA internuclear axis the orbitals combination will change leading to the formation of sigma and pi bond actually you see not only sigma pi even delta molecular orbital also form delta orbital molecular orbital is formed by the combination of what can you tell me can you guess yes it is formed by the combination of the d orbital formation কৰিলে তানি delta bond formation কৰিব sigma pi delta এটা ফৰ্মেশ্যন কৰিব f আছে f অৰবিটেল কম্বাইন কৰিলে কি ফৰ্মেশ্যন কৰিব তেনেকৈ আমি লিখিব পাৰোঁ ঠিক আছে আমি ডেল্টাটো নাচাওঁ বহুত বেছি কমপ্লিকেটেড এইবিলাক বস্তু আমি নাচাওঁ মানে ওকে এইবোৰ চোৱাও নাই নিজেও চোৱা নাই এইবোৰ চাই আছো বাকিখিনি কনচ কৰিছো আচ্ছা ঠিক আছে এতিয়া এনাৰ্জি লেভেলটো চাওঁ এনাৰ্জি লেভেল of molecular orbital less than 16 electron 16 electron less than 16 electron molecular orbital আছে ঠিক আছে ওকে ইয়াতে একেলগে আমি সব শিকি যাম যে কোনটো ষ্টেবল হ'ব কোনটো প্যাৰামেগনেটিক হ'ব কোনটো ডাইমেগনেটিক হ'ব একেলগে চাই যাম ঠিক আছে এনাৰ্জি লেভেল মলিকুলাৰ এনাৰ্জি লেভেল ডায়াগ্ৰাম energy level of four molecular orbital which is total electrons less than 16 suppose example sunbila see carbon 2 nitrogen 2 carbon monoxide etc sigma 1s sigma star 1s sigma 2s sigma star 2s done next sigma pi to py pi to px next sigma to pz next pi star to py is equal to pi star to pz greater than sigma star to pz okay these are the energy level diagram which is to be followed for the total electrons of the molecule which is less than 60. Suppose for nitrogen, how many electrons? 7 plus 7, 14. You have to fill up this. So I will starting from again. 1s, sigma star 1s, sigma 2s, sigma star 2s, pi to py is equal to pi to p x sigma to pz okay let's see how I'm filling this 14 2 1 molecular orbital 2 electron 2 plus 2 4 next 4 plus 2 6 8 whole done next you see whenever you see this type of orbital means the equal molecular orbitals whenever you see equal molecular orbital like this how will you fill up this first of all we have filled up this up to 8 electrons now we have left with 6 electron more in order to fulfill the 14 electrons okay so here I will give 1 and 1 first of all you have to give 1 and 1 why because they have equal energy we have to follow Hund's rule which rule Hund's rule means আমি এটা p যদি ইলেক্ট্রন থাকে p3 বুলি যদি লিখিছিলো p3 বুলি লিখোতে এনেকে লিখি দিম নেকি নো কেনেকে লিখিম আমি ফার্স্ট অফ অল সবকে আমি হাফ হাফ দি লব লাগিব হাফ হাফ দিয়াৰ পিছতহে আমি তাক ফিল আপ কৰিছিলো p3 is not like this p3 is not like this wrong therefore we cannot do this without filling up each orbital is 1 1 okay now see I have filled up with 1 1 now how many electrons are left now 8 9 10 so I can give more to 1 here more to 1 here means 8 6 8 10 12 so 2 2 2 2 to আমি কি লিখি 12 হৈ গল 12 8 10 12 now more 2 electron that is understood okay now you see magnetic behavior okay magnetic behavior how can you see any one unpaired electron means paramagnetic can you see any unpaired electron paired means paired hole ki hobo diamagnetic means the molecule will be not attracted through any external magnetic field of earth we have the magnetic field. That is the thing. Why the molecules? External magnetic field core particle. The external magnetic field, it is talking about the Earth. Okay. See, can you see any unpaired electron here? No. So N2 is diamagnetic. Diamagnetic. Okay. Now again you have to see the stability. Stability factor is that number of bonding should be greater than number of anti. Means number of electrons in bonding should be greater than number of electrons in antibonding. Star. These stars are called antibonding. So how many bonding electrons here? 2, 4, 6, 8, 10. Therefore it is stable. Molecule N2 is stable. Why? Because number of electron is bonding, means the electrons which are not present in the star orbital. It is called antibonding. Tactographical basis they are stable. Understood? Now moving on to the next part. Next example. Suppose say for next example. Suppose I am taking here carbon monoxide. Carbon monoxide, how much? Carbon monoxide, it will be carbon 6, oxygen 8, it will be again 14. Just 2, 2, 2, 2, 1, 1. Stop. Next, again 2, again 2. 12, 8, 10, 12. It is like the same for nitrogen. For carbon, I can see. For carbon, see. Carbon 6 plus 6. 12, 6, 8, 6, 8, 4, 6, 8, 10, 9, 10, 11, 12. For carbon, it will be diamagnetic. Carbon will be again diamagnetic. 2, 2. Understood? Carbon will again diamagnetic. Next C for again carbon nasami C2 minus next ki samami single atom D plus carbon 2 suppose C2 plus this is another C2 plus carbon 6 and minus 1 it will be 11 electrons. C2 plus is 11 electrons. So how will you form this 11 electron? Okay, this will be interesting example. Interesting means you will get to see. The one who is assessing means going through properly, they can understand. You see, up to this part, it will be same. 4, 6, 8. Next, 9, 10, 11. 9, 10, 11. 8, 9, 10, 11. Means now C2 plus you see 11. Magnetic behavior. See, magnetic behavior, how many unpaired electrons? 1 unpaired electron. That means it is paramagnetic. Okay, it can be in the presence of external magnetic field, it will show some attraction. External magnetic field. Okay. Now, molecular orbital energy level for molecular orbitals having electrons greater than 16, greater than equal to 16. For example, oxygen O2 minus O2, suppose N2 minus just like this. NO means nitrogen plus oxygen, NO minus. Okay, for this type of examples where electron is more than 16. 1s, sigma star 1s, sigma 2s, sigma star 2s. Now you see, Up to this point, both this configuration will have same energy. But there is an exception is there, means there is an abnormality is that sigma 2pz will have, this will come in forward for electrons having more than 16. But only this sense you have to take in account. Only this sense. Done. Next, sigma star 2pi, but this sigma star 2pz will not change its order here. It will have highest energy in sigma star 2pz. বুজি পাইছনে মানে কি কৈছো মই সিগমা 2pz টু কি হৈ যাব আগবাঢ়ি যাব যদি আমি more than 16 বা equal 16 ইলেক্ট্ৰন চাও কিন্তু সিগমা স্টাৰ 2pz টু আগনাবাহে এটো ভুল কৰিব নালাগে ই সদায় sigma star 2py and sigma star 2pz ৰ পিছফালে থাকিব it will remain in the last but only the sigma 2pz bonding sigma 2pz orbital will come forward okay due to because of some symmetry thing okay now in order to fill up the electrons suppose oxygen 16 1s 2s 4 6 8 8 হৈ গল 10 হৈ গল 10 11 12 13 14 understood 14 means 1 1 1 1 কে দিলো ইয়ালৈকে 10 হৈছিলে 11 12 13 14 এটো দিলো next again 2 2 থাকিলে আমি 2 দি দিম 14 15 16 understood 15 16 so O2 has 1 1 unpaired electron that means it will be dimagnetic it will be dimagnetic now stability you can understand stability whether it is stable or not number of bonding electrons how many you can see bonding electrons 1 2 means 2 4 6 2 4 6 8 8 plus 2 10 number of bonding electrons antibonding electrons 2 2 4 star electrons are called antibonding 2 plus 2 4 4 plus 2 again 4 plus 2 again 4 4 plus 2 again 4 therefore 10 minus 4 it will be 6 10 minus 4 it will be 6 6 by 2 equal to 3 no sorry here antibonding electron 2 plus 2 4 4 plus 2 6 it will be 6 therefore so what I have calculated here 2 is the bond order 2 is the what bond order from the bond order you have to understand about the stability whenever the bond order I think you can understand from now about this energy level diagram NO means 16 NO minus 7 plus 8 15 15 minus 1 16 N2 minus 16 again O2 minus 17 17 O2 minus will be 17 how can you fill up this O2 minus this one O2 minus it equal to 8 plus 8 17 2 2 2 2 2 next same how much 1 2 3 4 5 6 7 14 electrons we have already found 14 15 16 17 that means again 17 again it will be diamagnetic O2 minus it will be again diamagnetic now bonding antibonding so we are finding the bond order bond order how will you find half equal to number of bonding minus number of antibonding means half bonding how many electrons in bonding here for O2 minus bonding on keta ase 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10, 10. Antibonding, 2 plus 2, 4, 4 plus 2, 6, 6 plus 1, 7. That means 3 by 2, it will be 1.5. Bond order should be 1.7. Now you see, one question is very important. Why helium 2 will be not formed? Why helium 2 will be not formed? Why helium 2 is not formed but H2? Why? You see, for helium 2, how many electron? 2 plus 2, 4. Okay, 4 electron. Helium 2, 4, 2 plus 2, 4 electron. Its molecular orbital will be sigma 1s2, sigma star 1s2. Okay, sigma 1s2, sigma star 1s2. Therefore, bond order half. How many bonding electron? 2. How many antibonding? 2. Therefore, ultimately 0. Since bond order is 0, therefore He2 is not formed. It's a very common question. It might ask you about this. So bond order to stability. You have to find the stability, that which order is stable. You see, bond order directly proportional to the stability is also proportional to the bond dissociation. Understood? Bond order directly proportional to stability is also proportional to the bond dissociation. Now I give a quick trick to find the bond order stability, just like that. If you find the total electrons 14, bond order will be 3, then make it 13, 12, 11, 10. Next 15, 16, 17, 18. This is a very famous understanding trick. So decrease 0.5 in lowercase and uppercase also. Means in 14 you will have bond order 3. Total electrons, bond order 14, bond equal to 2.5. You have to decrease it by 0.5. I am telling you again. You see, total number of electrons you have find 14. Make bond order 3. Now, if you make a table like that, 15, 16, 17, 18, means bond order can never be 0. Bond order can only be 1. Bond order can never be 0 because our duta atom maximum bond, minimum bond they can make is 1. Maximum they might be 3. Actually, it is given as 3, but it might be more than 3 if you go more deeper. But we're not taking that more deeply. But you have to understand that maximum bond order is 3, minimum bond order should be 1. Mane molecular formation adal holo bond thakiboi. 1 bond means 1 attractive forces. 3 bonds means 3 attractive forces. Understood? Okay. So 14 I have taken 14 here. Now decrease 0.5 to 18. 0.5 decrease 2.5 to this is 1.5. This is 1. Now again you go upside. 13. Again decrease by 0.5, 2.5, 12 to 11, 1.5, next 10, it will be 1. So bond order will be 1 for total electrons. Suppose the question is find the bond order. Find the bond order for N2 plus. N2 plus means 7 plus 7 minus 1, 13. 13 means 2.5. Understood? Just you like that, you have to do. Okay, thank you. Please see the video very carefully. In revised means if you have any doubt, go 10 seconds, 20 seconds are here and go. Okay, main part is features and combination of atomic orbitals and this part. Okay, thank you.